Again, class. So for today's presentation, we're going to talk about the truth values and the truth tables, still on the concept of logical statements. So how are we going to evaluate whether or not a particular statement is a true statement or a false statement based from its truth values? So first thing is if you happen to encounter a compound statement either in symbols or not yet in symbols, and if you're going to symbolize them, now we have to use the concept class first of the hierarchy of connectives. So a hierarchy of connectives is being agreed upon, and it tells us which connectives should be done first when there are no parentheses to guide us. So of course, the first in terms of priority to simplify is the negation. Then the second highest connectives that we simplify first will be either your conjunction, which is your and, or the disjunction, which is your or, then followed by the conditional, and the last is your biconditional. So if you happens to have combinations of these connectives, then we have to apply which one should be done first before the other will be the one. So the connectives higher on the lists are done first. So the connective that is lowest on the lists is done last. So it describes the type of statement overall. So if we have here E connectives, okay, that contains two and there is no parentheses, so we have to apply the hierarchy of connectives. So we notice here that we have our disjunction, which is the or, and that of the if then statement, which is now our conditional. So we know that the disjunction is higher than the conditional, so we have to rewrite this in such a way that we are going to simplify first what is the disjunction. So meaning we are going to simplify first the statement P or Q, then whatever is the result, then the next now is to simplify the result of your P or Q with that of your R using now the connective if and then or your conditional. So it's very important, class, if you have your open and close parentheses, because this will tell us which one should be done first. Now, a statement like this one, P and Q or R, this is very ambiguous, class, because from the rules, it's either your connective and or your connective or should be done first. But since they have on the same level, so it doesn't matter which one should be first because these two connectives are in the same level. So either we can have it as P and Q, okay, simplifying it first, P and Q before you use now the or to your R, which is now a conjunction. Then it could also be the same if you're going to simplify first using the disjunction, your Q or R first, then whatever is the result, then you can connect that to your P with E conjunction. So because the connectives and or the conjunction or the disjunctions are of equals, okay, in hierarchy, so you can have this either, okay, you can simplify first your conjunction or you can simplify first your disjunction. Okay, so let's apply the hierarchy of connectives here. So the statement if P then Q or R, because there is no parenthesis and there are two connectives involved, so we apply which one is higher than the other, and we know that your conjunction and is higher than your conditional, so we can rewrite this in this manner. So you have to put a parenthesis between your Q and R first, so meaning that this will be done first before you apply now your conditional. Another example is this statement. So there are three different connectives used. So we have your disjunction or your biconditional if and only if, then you also have your conjunction and. Now we know that your disjunction or your conjunctions are of the same level, so we can simultaneously simplify first between P or Q and that of your Q and R. So by putting now a parenthesis, so it means that you are going to simplify first, okay, between your P or Q and of your Q and your R. So whatever is the result, then that's the only time that you can now apply the biconditional, because this is of the lowest hierarchy. Now the statement here, if P then Q, if and only if R, so we have uh, two different connectives involved. So we have your conditional and your biconditional, and by the hierarchy class, we know that your conditional is higher than the biconditional, so meaning you have to simplify first your conditional if P then Q, then whatever is the result, then you have to simplify that by your biconditional connecting to your statement R. So again, if you don't have any parentheses involved, then we have to apply the hierarchy of connectives so that we know which one should be done first. So when we say truth value, so sometimes class, a statement is identified as true or false, then combined with the connectives, then if you're going to evaluate the entire compound statement, whether it is true or false. So this is what we mean by the truth value. So if one of the statement is true, the other one is false, then if you're going to combine, will it be false or will it be true? So that depends now on the particular connectives. And this is where we are going now to use our truth table. So in math logic, a truth table is a chart of rows and columns that shows the truth value, whether it is a true or it is a false statement, or of course the possible combinations of more than three, and that will give us more combinations. Okay, so usually represented by the lower cases letters are your statements, so we use the P, Q, R, and S. So sometimes class we use the capital letters, and of course as operated by the logical connectives using now the four uh, connectives that we use, the and, the or, the if then, and the if and only if. Now these are the four tables that we usually use. So we have the conjunction, then we also have the disjunction, the biconditional, the conditional, and that of the negations. And based from the four combinations class, because we only have two statements involved, so we usually have four combinations of your truth values. So either both are true, one is true, the other one is false, or the first statement is false, the second statement is true, or both the statements are false. So these are already predetermined class, or these are already designed or given to us, okay, its truth values. So using the conjunction and, if both statements are true, then it should be true. Otherwise, if one of the statements is false, then everything else is false. So this is for the conjunction and. So to make this statement, compound statement true, then it must be that both statements should be true. Otherwise, if one of the statements is false, then it will be a false statement for the conjunctions. For the disjunction, because the disjunction is using the word or, so either one of the statements is true, then the entire statement is true. But if both statements are false, then the entire statement is a false statement. Okay, so we use this a lot class to guide us so that we can know which one, okay, will be used and what is the truth value for the combinations. And of course, for the biconditional, so this is your if and only if statement. So if both are true statements, then it is a true statement. But if both are false statements, then it is still a true statement. Otherwise, if one of the statements is false, then the entire biconditional statement class is a false statement. For the conditional statement, we have this truth table. So if both are true, then it is a true statement for conditional. If both are false, then it's still a true statement for the conditional. If the first statement is false but the second statement is true, then the entire conditional statement is true. So this is actually referring to uh, the premise and the consequence statements. Okay. So if the other one, if the first statement is true and if the second statement is false, then the entire conditional statement class is false. And sometimes we also use the negation. So the negation class is simply the opposite. So if the original statement is true, its negation is false. Or if the original statement is false, then its negation is true. You can also rewrite your table in this manner where you can see already the results where one of the uh, statements is true, the other one is also true under the conjunction. So they are the same compared to the previous one. So it depends on your class on how you are going uh, to choose on a particular table, whether you like it the first one that I presented or you want it like this one. So say for example, if you are going now to validate or evaluate a certain compound statements given that the statements are true or false, then what would be the result if you're going to evaluate it? So say for example, if the statements P and R are true statements and Q is a false statement, then find the truth value of the compound statement as given. Now here you have several uh, connectives used, although there are two, okay, but there are also two negations done here. So what we're going to do is that we are going to copy the given statement, then based from the statement that P and R are true and Q is a false statement, then we have to change the uh, alphabets or the letters by its truth value, because P and R are said to be true, then Q is a false, then we have to substitute. Then we apply the rules. Now here we have our conjunction. So under this, uh, inside the parentheses, true and false. So you have to find here what is true and false. So true and false is false. And at the same time, it's being negated. And here you have your negations to be not true. So when you say not true, it means that it is a false statement. So notice the changes class that true and false is false based on this uh, table, then not true is also false. But since we still have a negation of not false, again, you have to simplify that further. And what we have now is true or false. So in this case, we are already done with our and because we already simplified this one. So what remains now is our or a disjunction. So again, true or false, then under the disjunction, true or false is this one, then it is now a true statement. So looking at this one, okay, this is supposedly true or false here at the bottom, and we can now say that this entire, okay, compound statements is a true statements, given that P and R are true and Q is a false statement. Okay, then another example here. So similarly, if P and R are true statements, Q is a false statement, then find the truth value of the compound statement given by this. So there are lots of negations, although there are only two operations here or two connectives used. We have your conjunction and your disjunction or. So again, we copy our given compound statements in symbols, then we are going to change the truth values that represents each statement. So again, P and R are true, Q is a false statement. Then, of course, we have to simplify first, okay, the negations, okay, before we apply the others. So here, not true is false, then here, not false is true. But still you have your negation here, but because this one is within or inside the parentheses, so it means that you have to simplify first what is inside the parentheses. So true or true is true. Okay, so we change that now to true, but then again it is negated, so not true is false. So in this case you already have your false here, and still we have our conjunction and, so false and false. So by looking here, false and false is false, then we already have the result as false. So therefore, this compound statement is a false statement class. Another one is this. Okay, so here we have two conditionals and a conjunction. So again, P and R are true statements, Q is a false statement. So we are going to, of course, write first the given compound statements, then we change the truth values for each statement. So P and R are true, but Q is false. So we change that, then we simplify. So here we have our conditional. If true, then true. So we have to use one of these combinations here. So this is true. Then you negate, not false. So that is true. Okay, so by negating this one, so what I did here, class, is that I already applied the rules here. So if true, then it is true. So I have here the true. Still, I have to copy this conditional. Then I negate, not false, to be true. Then I have again another connectives. This is your conjunction and. So true and true is true. Then what we have is already if true, then true. So again, looking at the conditional here, so true, true here, then the entire result is a true statement. So therefore, this compound statement, given that P and R are true and Q is a false, is a true statement. So this is how we evaluate class compound statements, provided that the given statements has already its truth values. Then all we have to do is to apply the rules. Then we are going to simplify it based on its truth values. Now, if you are not given class the truth values for each statement, and if you're going to find out whether or not it is a true statement or a false statement, then that's the time that we are going to create a table. Okay, so we create a truth table similar to this one. So going back again to our truth table values, so these are fixed. This is applicable class if we have two statements, and these are the combinations. So we use this a lot so that we can identify its truth values. Okay, so if we have this, it is not raining and I am going to a movie. So if this is the compound statement, then this is rewritten as your if not Q and R. So you can use any letters class to represent the two statements. You can use X, Y, you can use A and B, okay? But you have to use the appropriate symbols to denote your connectives end. So what we're going to do here is that we construct and use the truth table to determine the truth value of these compound statements to be true. So in other words, what will be your statement if this is your Q statement, this is your R statement. So would it be both true or both false, or one of these should be true, the other one is false, so that the entire compound statement must be a true statement. Now, because we don't have anymore the truth value for each statement, so what we do, class, is we are going to create a table. So here, because our connective is and, so we are going to use the conjunction as our basis here. Okay, so you can change your letters or your variables instead of P and Q. But again, as I said, this is our guide. Then we can recreate a table that is based from Q and R. So if we do that, So I have here my Q, I have here my R, then I just copy from this conjunction table. Then I have the negation because we have here your not Q, then I will going to negate not Q. So from true, it becomes false, the false becomes true. So I will be only dealing class with R and not Q because this is the one that we are asked for. Then you can create another table, rearranging them. Okay, so this is not Q, this is your R. So we just copy the combinations. Then we apply now the rules. So here you have your AND. So again, the AND here, basing from this conjunction, it is only true when both are true. So accordingly. So you could see here, okay, our guide that if both are true, then it is true. Otherwise, if one is false, the other is true, or both are false, then it should a false. It should be a false statement. So here, false and true is false. False and false is also false. True and true is true. Then true and false is false. So going back to the question, construct and use the truth table to determine the truth value of this compound statement to be true. So here we have four possibilities, and the only one that makes this compound statement true is that your statement should be both true to make it true. So in other words, it is not raining should be true, and I am going to a movie should also be true, so that this entire compound statement is a true statement. So this is the case class, okay, when we don't have the truth values for each of the given statements. So instead, we create a table. We are going to find the possibilities of what makes this statement a true statement or a false statement. So it depends on the question. So another example is I am not going to the basketball game, or I am going to a movie. So given by these symbols, so the connectives used is or, so we have our V to represent or. So this is a disjunction. Then we have here construct and use truth table to determine the truth value of your compound statement to be true. So in other words, what combinations can we have so that the entire compound statement is a true statement? Could it be that one is true, the other one is false? Could it be that both are true or both are false? So that's the one that we're going to build or to create. So again, this is based on a disjunction, okay, from the table. So these are the truth tables for the disjunction. Then we can create based from the given statements or the letters that it uses. So here, instead of P and Q, we are given your S and R. So I can have my R followed by S. It doesn't matter, class, which one. If you want your S first followed by R, it doesn't matter, okay? So our R here, then my S, then again I have to copy these combinations here: true, true, false, false, true, false, true, false. Okay. Then if you're going to reverse this, it's the same class: true, true, false, true, true, false, false, false. Okay. Then because I have my negation here, then I have to negate my S. So all the true becomes false, the false becomes true. Then going back to the compound statement, then we can create. So by rearranging, so because not S is first, then I have to rearrange this. So not S, then copying. Okay, then R is here. Then we apply now the rules. So not S or R, okay, because it's a disjunction, according to the disjunction rule, is if one is true, then it is true. But if both are false, then it is a false statement. So here, we just look for a true. One true will do. So false true is true. True or true is true. False or false is false. Then true or false is true. So we have here the four possible answers. Then we go back again to the questions. We are asked to be true. So which of these four is a true statement? So we have here three possibilities. So we could now see here, class, that either one of the statement is true, the other one is false, then the entire statement is a true statement. Or if both statements are true, then the compound statement is a true statement based from this result class. Okay, so either the first statement is true or false, but the other one is the opposite, or both are true, then we know that the compound statement is a true statement. Okay, then we have another one. If it is not raining, then I am going to the basketball game. So represented by this compound statement in symbols, not Q, then S. Here you have to construct again a truth table, but you are going to find out that the result is a false statement. So meaning, oh, what makes this a false statement? Okay, so that's one that we're going to find out. So here, because it is a conditional, then look for the table that is conditional. So these are the truth table for the conditional. Okay, so as I said, you can rewrite your PQ into Q or S, okay, or S or Q. It doesn't matter, class. So I'm just changing the letters from P and Q to Q and S. Okay, so I'm just changing them, but again, I have to copy the combinations here. So true, true, false, false, true, false, true, false. So they're the same here. Then, because the symbolic logic here class, it made use of a negation, not Q, then I have to negate the Q. So that all the true becomes false, the false becomes true. Then I will be rearranging this again. Okay, if I need to come up with another table, it's okay to have one. Then rearranging them. So not Q first, then we copy. Then our S, then we copy. Okay, so we already have our combinations. Then we apply the rules. So this is your conditional. So these are now the results. So if both are true or both are false, then it is true, or false true is true, but true false is false. So here false true is true, both are false, it should be true. Both are true is also true, then true false is a false based from this one class. True false is false, okay, but false true is true. So here we already have the possible results. Because we are asked class which one is a false, so which combination is a false, so here we can already see that this is the only possibility that the compound statement is a false statement. That is, if it is not raining, or it is not raining should be true, then I'm going to the basketball game should be a false statement, so that the entire statement or the entire compound statement class is a false statement, because that's the one that we are asked, okay, to make it a false statement. Okay, now for the biconditional, I am going to a movie if and only if it is not raining. So how are we going to find out whether this one is a false statement? Because we are asked to create or construct a truth table, then determine that it is a false statement. So we need to find a table for a biconditional as our basis. Okay, then we create a table that is based from R and Q. So as I said, you just change the letters. Instead of P and Q, you use R and Q because this is given. And we are going to find it, okay, to make it a false statement. So again, this is my R, this is my Q. I just copied the combinations from the table. Then we have the negations of Q because it is given. Then I have to negate the truth values for your Q. So as I said, the true must be false, the false will becomes true. Then rearranging this from R first, then to not Q. Okay, so we just rearrange. Then we apply now the biconditional. For the biconditional rule class, both should be true to make it true, or both should be false to make it true. The rest are false. So in this case class, so true should be true, or false is true. So you have here the true, then the rest are false. But going back to the question here, we are only looking for the combinations that is a false statement. So Here we have this as a false statement, and the other one is this one. So these are the only possibilities. So in other words, class, one of the statement is true, the other one is false, then the entire statement is a false statement. Meaning, I am going to a movie is true, then it is not raining should be false. Or, I am going to a movie is a false statement, then it is not raining should be a true statement. So that this entire statement, compound statement, will be a false statement. Okay, so this is how we evaluate class or create a truth table based from the given conditions. Okay. Now, sometimes we're just going to create a table, okay, given this statement. So this is getting more abstract na class. So we do not know what this P represents, okay, or what is this Q represents. So we're just going to find out, okay, what will be the truth value for this statements, compound statement. So notice here, class, that you have two operations involved. You have your or this is your disjunction, and you have your conditional. So again, this is given, and we notice that this is in the parentheses, so it means that we have to simplify this first. Okay, so what we do is, of course, we need this table for the conditional for your Q, K, and P. Then we also need later on your table for your disjunction. Okay, so what will I do is, this is the original conditional. Then because I am given Q, the plus P, then you notice that I interchange. Okay, so from the original, then I just interchange Q and P. So I interchange their positions, then I apply the conditional. So in the conditional class, be mindful. Okay, if both are true or both are false, then it's a true statement. But there is one here that if the first is false, the second is true, then it is true. Otherwise, if the first is true, the second one is false, then it is a false statement. So we have to apply that rule. So both are true here. So we have true. The first one is false. The second one is true. So it's a true. The first one is true. The second one is false. So it is a false. And both are false. Then it must take a true statement. So this one here, class, is already our truth table for this part only. Okay, but we don't have yet the whole compound statement. So we have to carry this one to the next, okay, by, of course, we already finished this one. So this will wait. Then we create another table for the negation of your P. So if this is now our P in the original, by negating it, it becomes false, false, true, true. Okay, so we have this one. Then you notice that these are the things that we need to combine. So we create another one here. Okay, so not P, this is your conditional here. Then it made use of your uh, or this is your disjunction. So again, we have to use the concept of the disjunction. So meaning, in the disjunction or statement, if one is true, then the entire thing is true. If both are false, then the entire thing is a false statement. So dito po sa disjunction, we are just going to look at whether at least it contains one true to make it true. Okay, so of course, false or true is true, false or true again is true, true or false is true, then true or true is a true statement. So any of these combinations, class, will always give us a true statement. So if this happens, class, this is what we call a tautology, meaning no matter what combinations we are going uh, to combine here, whether both are false, both are true, one is false, the other one is true, the result, class, is always a true statement. So if this happens, then this kind of your compound statement is what we call a tautology. So any combinations, the result is always true. And that is what it means by tautology. So para siyang ano siya, class, para siyang hindi naman siya theory. Okay, pwede rin, pwede natin masabing theory siya, class. that it is always true as long as you have to prove that it is a true statement. Yan. Another example, if we have, let's say this one, okay, then we are going to find out whether or not which of the combinations will give us a true statement or a false statement for this kind of compound statement. So again, you have to notice, class, that we only have one operation or one connectives used. This is your conjunction, which is and this is now the table for our conjunction. So we have only P and Q, but I noticed that we have the negations of P, likewise the negation of Q. So what we do is, if I'm going to negate the value of your Q, so again, the true becomes false, the false becomes true. Then I can now have the first one. Here I have P and not Q. So I have P and not Q here. So the word is and, that is conjunction. So it should be that both should be true so that the conjunction is true. So true and false is false, true and true is true, false and false is false, false and true is false. So we have the result already. So this one represents this one, what is in the parentheses. Then we create another table. We can extend it because the second one here is your negation of your P, but we have our conjunction again. Okay, so our negation of the P, so where did I get this one? Again, remember that this one is from this one. So I just carried it out, then I negate it so that all the true becomes false and false becomes true. Then I'm going to copy this part here, put it here, then I'm going to apply now the rules. So applying the rules here, so I have my and. Okay, so here. Ayan. So and. This is conjunction again. So both should be true to make it true. Otherwise, it is a false statement. So false and false is false. False and true is false. True and false is false. And another true and false is also false. So here you notice that the results are all false. So no matter what, whatever combinations you can have here, the result is always a false statement. So this is the opposite of your tautology. So if this happens, class, any combinations, the result is always false. This is what we call a contradiction. Okay, ayan. So if all the combinations, okay, if the statement is false for all the combinations, then this is what we mean by the contradictions. Now, sometimes, class, you have uh, a combinations of true or false as the result. So we just call it now, we don't have a particular name for that one. Okay, we just call it a contingency. Okay, however, if the results are all true, tautology. But if the results are all false, we call it contradiction. Okay, so this is how we create, class, a truth table or a truth value given a compound uh, statements in symbolic form. Okay, so once again, class, so thank you for your time and see you next time, class, for the next lesson. Goodbye.